Good morning to everyone. Today we are going to see about pulmonary ventilation and surfactant. First we'll see in few slides about pulmonary ventilation, then we'll go for the surfactant. We see about ventilation in respiratory system. There are two types of ventilation in respiratory system: pulmonary ventilation and alveolar ventilation. Pulmonary ventilation is otherwise called as minute volume. It means the ventilation takes place in the lungs, that is, volume of air is moving in and out of the lungs per minute in quiet breathing. Pulmonary ventilation is calculated by multiplication of tidal volume and respiratory rate. Tidal volume is the volume of air breathed in and out of lungs in a single normal quiet breathing. The normal value is 500 ml, whereas the respiratory rate is 12 to 16 breaths per minute. So as of by calculation, it gives 6 liters per minute. So the pulmonary ventilation or minute volume value is 6 liters per minute. The second one is alveolar ventilation. That means the ventilation takes place in the alveolus. So as of in diagram, this is the alveoli and this is the pulmonary capillary where the gases exchange take place. The amount of air moves for gases exchange in the alveoli every minute. So it is calculated as tidal volume minus dead space into respiratory rate. As we already know about tidal volume and respiratory rate, will go for the dead space. Dead space means is a part of respiratory tract where gases exchange does not take place. It starts with the nose to the terminal bronchioles. So the normal range of dead space is 150 ml. So by the calculation, the alveolar ventilation will get the result 4.2 liters per minute. Now we'll see about respiration. There are two types of respiration: external respiration and internal respiration. External respiration means movement of oxygen from the lungs to the pulmonary capillaries, whereas carbon dioxide from the pulmonary capillary to the lungs. This we call it as external respiration. Internal respiration means movement of oxygen from the blood into the tissue, whereas carbon dioxide from the tissue into the blood. This is mediated by transport of gases. Once the gases reaches the blood, it transported and reaches the targeted area. As we briefly saw about pulmonary ventilation and alveolar ventilation. Now we go about the second topic, surfactant. We'll start with the surfactant with the easy and simplest question. At what gestational age is surfactant produced? It produced at exactly at the week of 24th and 28th in feeders to keep the alveoli from collapsing. Then what is surfactant? It is defined as surface acting material or agent that act on the alveolar membrane that reduces the surface tension. Here the three important words are present. One is surface acting material or agent, that we call it as surfactant. Here the blue color layer we call it as surfactant, and the alveolar membrane, this is the alveolar membrane. Reduces the surface tension. What is surface tension? This tension developed on the surface of the alveolar membrane, we call it as alveolar surface tension. Now we have a doubt how the surface tension is created in the alveolar membrane and what it will do. If you know the answer for this question, we will understand about the surface surfactant. First we'll see about how the alveolar surface tension is generated in the alveolar membrane. The alveolar wall are lined by a thin film of water which create a force at the surface called surface tension. See here, this is the water molecules. These water molecules create a force on the surface of the alveoli that produces a surface tension. Now there is a surfactant, so this agent reduces the surface tension. In the second diagram, there is no surfactant, so more surface tension will be developed. If more surface tension is developed, what it will do? It has a tendency to reduce the size of each alveolus, thus resulting into recoiling tendency of lungs. What happens if the alveolar surface tension is not kept low? When the alveolar becomes smaller during expiration, if the alveolar surface tension is not kept low, it leads to further smaller the alveoli leads to collapse the lungs in accordance to law of Laplace. So this slides indicate during expiration the alveoli become smaller in normal state itself. So due to the presence of surfactant, the surface tension is kept low. Then the alveoli go for the inspiratory process, that it will be expanded. For if the surfactant is not present, the alveolar surface tension is not kept low. This leads to further smaller the alveoli, causes collapsing the lungs in accordance to law of Laplace. Then you want to know what is law of Laplace. What is law of Laplace? Law of Laplace is defined as in a spherical structure like alveoli, the transmural pressure is directly proportional to the twice the surface tension and inversely proportional to the radius. Here, the spherical structure of alveoli. This is the spherical structure of alveoli. And the transmural pressure means the pressure difference between inside the alveoli and the outside the alveoli, which indicate as capital P. And T2T denotes twice the surface tension. We already know the surface tension means the tension is created here is twice the surface tension, is directly proportional to the twice the surface tension and inversely proportional to the radius. So from this diagram we clearly understand that if the radius is small, the pressure is more. If the radius is high, the pressure is low. So thus, if the radius is small, the surfactant is not present, so the surface tension will be created more, that leads to collapsing tendency. Thus, a small alveoli tend to become smaller by surface tension, which leads to collapsing tendency of lungs. How it is prevented? It is prevented by surfactant. Where the surfactant is synthesized. The surfactant is synthesized by two important cells, type 2 alveolar cell and Clara cell. The type 2 alveolar cells is present in the alveolus. See here, this is the alveolus. It contains two cells, type 1 alveolar cells and type 2 alveolar cells. The type 1 alveolar cells present in the interstitial fluid, the type 2 alveolar cells present on the surface, that will synthesize the surfactant and forms a film on the surface of the alveolar membrane. Thus it reduces the surface tension. The second important cell is Clara cell that present in the bronchioles, that also synthesizes minimum amount of surfactant. What are the composition of surfactant? The surfactant is a lipoprotein complex. It is made up of the important phospholipids dipalmityl phosphatidylcholine, phosphatidylglycerol, and it also contains proteins and carbohydrates. The important proteins and its functions are SBA, SBB, C, D. The function of SBA is uptake of surfactant for reuse. The function of B and C, we already see the film of phospholipids. These proteins only help to form a monomolecular film of phospholipids on the surface of the alveolus. SPD function is innate immunity. This diagram indicates the formation and metabolism of surfactant. Both are similar diagram. This is the type 2 alveolar epithelial cells which contain the nucleus, endoplasmic reticulum, and this is the Golgi apparatus. Once the information comes to the nucleus, the proteins and lipids will be synthesized. It will be packed in the Golgi apparatus. Once the particles will be packed in the Golgi apparatus, it is converted into laminar body. This blue color, the violet color indicates the laminar body. By the exocytosis process, it will be secreted in the alveolar lumen as tubular myelin. Now this tubular myelin with the help of the protein will be spread as a monomolecular film of phospholipids. This is the monomolecular film of phospholipids which contain the hydrophobic and hydrophilic end. The hydrophobic is head and the hydrophilic is tail portion, which helps to reduce the surface tension. Both are similar diagram. This is the type 2 alveolar epithelial cell. Now we'll see the function of surfactant. So already we saw about the how it reduce the collapsing tendency of lung. So by reducing the collapsing tendency of lung, it maintains the stability of alveoli of lungs. The third important function is incontinent breath. It prevents the collapsing of lungs for the birth also. So how in fetus the lungs are solid and not expanded. First breath starts soon after birth, although the respiratory movements are attempted by the infants. The lung tend to collapse repeatedly, and the presence of surfactant in the alveoli prevents the lung from collapsing. The third one is it prevent pulmonary edema. How it prevent pulmonary edema? So let me see this diagram. So this is the normal one. This is the accumulation of fluid in the lungs, inside the lungs. We call it as pulmonary edema. So because inside the alveoli, the pressure will be created more. So due to the pressure increases, the fluid from outside get inside. Then the pulmonary edema will occur. And also it destroys bacteria and virus by hydrophilic proteins SPA and SPD. Applied aspects. So if the surfactant is deficiency or absent in the child, we call it as hyaline membrane disease or infant respiratory distress syndrome. Or if the surfactant is deficient in adult, we call it as adult respiratory distress syndrome. It is caused by shock, systemic infection or trauma, pulmonary hemorrhage, pulmonary edema, and cigarette smoking. Exogenous surfactant is available to improve the symptoms. Now we'll go to the third important topic, pulmonary compliance. It refers to changes in lung volume per unit, change in transpulmonary pressure. Transpulmonary pressure is the pressure difference between the alveolar pressure and the pleural pressure. So compliance is equal to volume by pressure. This indicates if the volume of the lung is increases, the compliance increases. If the transpulmonary pressure is decreases, if the transpulmonary pressure is increases, the compliance decreases. So thus it expresses the expansibility of the lung and chest wall. So compliance is nothing but expansion of the lung and chest wall. That's all. So the normal value of the lung alone, the compliance of normal value of lung alone is 0.2 liters per centimeter water. For lung and chest is 0.13 liters centimeter water. For thorax alone is 0.22 liters per centimeter water. Understanding purpose, when volume of lung is more, the compliance is more. I already know that it's directly proportional, and that is transpulmonary pressure is indirectly proportional. So person with one lung will have less compliance than those with two lungs. Elephants compliance will more when compared to small animals. Condition, the compliance is increased. Aged person, aging is associated with reduction in chest wall compliance and increased air trapping. There is an increase in airspace size with aging resulting from loss of supporting tissue. Emphysema. In emphysema, there is marked increase in airspace due to loss of many contagious alveolar wall, that is elastic property lost. In what are the conditions? The compliance decreases. In restrictive lung disease like pulmonary tuberculosis, fibrosis, due to destruction of functional lung tissue, they must generate more force to expand the lungs. The some other factors like pulmonary edema, thoracic deformity like kyphosis, scoliosis, injury to chest, respiratory distress syndrome of newborn. So these are the conditions the compliance decreases. Thank you very much for your kind attention.